I've just completed an upgrade to this Volvo Penta 8.1 GI-B engine. It's an inboard running through a jack shaft. It's mounted quite low in the hull, in the middle of the boat, which is ideal for handling in a seaway. But the Volvo Penta has long had a problem called water ingestion, which is kind of like a misnomer. But what it really means is that somehow water gets back through the risers into the manifold and compromises the exhaust valves on the engine, usually resulting in an engine rebuild at the very least. Long been a problem, and mostly because of the design of the Volvo Penta cast iron risers. There's also a wet joint where water flows from the manifold into the riser through a joint that's gasketed between those two components. And this is a source of a lot of problems also from corrosion and from leakage, both into the engine and exterior into the engine. So the first step here was to do away with the Volvo Penta cast iron manifolds and risers and install a stainless marine product that uses custom stainless risers and aluminum manifolds. There is no wet joint. It's water is normally plumbed for Volvo Penta from the manifold into the riser through a separate connection. This is the output, typically on the manifold, flows around the joint and into the riser here and cools the riser and exits very far downstream. Okay, this eliminates most problems, but not one, and that is condensation in the manifolds. When running at low speed with raw water manifolds, they're overcooled. Condensation usually builds up in the engine and in the manifold, flows down to the bottom, and you guessed it, that's where the exhaust ports are, and presents problems with extended low-speed operation. Now you can burn that off. Some people have what they call a shutdown procedure. You run the engine for 2 minutes at 2,000 RPM to build up heat and burn that out. But it's still seawater in the manifolds. And that's why they overcool at low RPM. So here's probably, maybe, possibly the first ever 8.1 Volvo Penta 8.1 converted to use glycol heated manifolds. This is made only possible through use of the stainless marine risers and manifolds because they have separate water systems and they're connected through a pipe or not. The exhaust joint is here. There's no water flowing through the exhaust joint like in your cast iron versions. So what we had to do to make this work is first, in the Volvo Penta, water comes out of the crossover pipe in the front of the engine and goes immediately into the heat exchanger, and the manifolds are not part of that equation. So what we had to do is do away with the cast iron tower that directs the flow directly from the engine into the heat exchanger, and instead install a Edelbrock gooseneck down there and pipe it into a 90-degree 1.5 hose and come back into a distribution box that splits the flow. Instead of sending it to the heat exchanger, splits the flow into two 1-inch pipes that flow back and down and around and into the bottom side of the manifolds right here. And then the water flows up through the manifolds to a fitting in the top, 90-degree fitting, which is connected to a hose, which flows back to a remote thermostat housing. And this one's mounted to the bulkhead, on the forward engine bulkhead, simply because there wasn't enough room to mount it on the engine. So we didn't. Likewise, port side, flow comes back, goes down through this pipe and around and into the bottom of the manifold in a similar manner. Flows up through the manifold, comes out through this hose and around and around and around. That hose is quite lengthy. Comes underneath the raw water hose and around and flows up to the starboard side of the engine and up to the other port on the remote manifold. So that's kind of how the fluid gets into the remote manifold. Now, in a Volvo Penta system, as in a Crusader system, the bypass is used to, the bypass port on the circulation pump is used to draw fluid past the thermostat. So that heats the thermostat as the engine and riser and manifolds warm up. So this is a valved bypass, same as Crusader. As the thermostat opens, the bypass port is shut off. That's what required this rather cumbersome arrangement here. But so the thermostat, when it opens, shuts this hose down. But before the thermostat opens, flows coming back from the manifold, hot coolant, passing the thermostat and flowing through this hose into the original Volvo Penta hose. I left that. It was important for me to maintain that because that's for reasons I'll get to in a few minutes. So when the thermostat opens, the bypass is closed off, this hose is shut down, and all the flow then flows directly into the heat exchanger. So long roundabout route from what it used to be, but now we have the manifolds are heated with coolant, glycol, same as the engine. It required 7 additional quarts of glycol to bring the system to mostly full. There's some air bubbles, I'm sure, in all this complex hosing, but they'll work themselves out as the engine starts to pump fluid through the engine. While all these hoses look like a lot, this is exactly functionally identical system to what's installed on Crusaders. Mainly a remote thermostat housing. The fluid is sent to the manifolds first, through the manifolds and back to the remote housing, which is usually back on the heat exchanger mounted in the rear of the engine, across the rear of the engine here, and then into the heat exchanger itself once the thermostat opens. And in a Crusader, it also closes off the bypass when the thermostat opens. Now, this entire experiment depends on the capacity of this guy, the heat exchanger. It was installed for a half system. There are mixed reviews on whether it has the capacity to handle the manifolds as well. Most people say yes, some people say no. So it could be possible that I may end up tearing all this out and going back to stock, which is sort of why I tried to retain as much of the original equipment on the bench, or in the case of that, bypass hose, so that going back is not catastrophic. Yes, I lose the investment in the remote thermostat housing and in the distribution box, but other than that, I can get back to where it was before if the heat exchanger has insufficient capacity. And we'll know that in about 2 weeks. The boat comes out of the shop and we'll run it on a hose and run it up and see what get the air bubbles out of the coolant system and see how she behaves running on a freshwater hose. And if that looks good, then we'll splash it, tie it up to the dock and run it there. Instead of pressure from a hose sucking the water in, there might be a little bit less flow, there might be more. A hose might be restrictive or not. We'll run it up there, then we'll go out, cast off, run out, do some low speed runs, and if everything still looks good, put her up on plane. Cruising speed, if still looks good, just open her up, 40 knots, maximum engine heat, see what happens. So that's the plan. Have any questions, feel free to drop me an email, and we'll take it from there. Thanks very much. Okay, we're kind of like doing the initial run up here. Lit off the engine and checked the raw water and coolant hoses for any kind of leaks. Found nothing. I could feel the manifolds warming up. I could feel the distribution box warming up, and the remote thermostat housing starting to warm up. So we're Coming up from a dead cold start of about 50 degrees Fahrenheit. We're going to see, we're running it, like you can see, 1500 RPM. Got 50 pounds of oil pressure. Looks like we're holding it about 150F right now. Maybe she'll climb a little bit. Should climb a little bit. This is engine coolant here, engine temperature, and a digital readout. And all the plumbing I did should have increased the flow through the heat exchanger a lot. I mean, there are lots of restrictions in the VP setup, cast iron setup. And 162. Wouldn't hurt my feelings a bit if it stayed below 170. This is riser temp, port riser. Roughly about 58 degrees. Starboard riser is about 60. Thermostat should be fully open now. And the bypass closed off, so all the flow should be now flowing through the heat exchanger. Now this engine always ran at 174 to 175 with the Volvo Penta setup. My gosh, it looks like it's stabilized at 163 to 164. Now, mind you, the water's very cold coming out of the well, but it's a very small aperture. It's only like, I would say, less than ½ inch ID where the hose fitting feeds into the freshwater flush system. I would expect the riser to run cooler, but you won't really know until there's a load on the engine. Okay, we're going to take her back down to close to idle and check the hoses, make sure there's still no leaks, and look at the coolant levels. Coolant levels holding steady. I added about a pint after she ran for a few minutes. Oh yeah, those are hot. Ow, that's hot. That's hot. Those hoses are all hot. Those hoses are very cold. That's raw water. These aren't even warm. Happy to say, no leaks. Should idle right at 550. 169, 168. Probably a little bit of raw water starvation, but I'd like to see this idle for a little bit. So let me go get the thermostat. We'll let that idle. And I'll be now, this is what I was talking about when I said the aperture on the hose feed. That's it, right there in front of my thumb. I doubt that can be much over 3/8 of an inch, if that. Now the pump pressure is 90 psi, so the pressure has some effect, but that's an awful small inlet to be cooling your engine with. Gotta kind of love that sound. Okay, it looks like she's gonna run about 5 degrees hotter on an idle. So let's see if that comes back down when we bring it up. Yeah, that just tells me that there's not enough flow through the hose fitting. You should do better on the raw water pump with a 1-inch hose instead of a 3/8 inch. Teething aperture. Okay. Okay, let's take a look at some temps. Before, it is a little bit cooler than the water temperature at the center. This should be nice and hot. Well, not. What's that? That's 130 right there. That's where the manifold flow comes back in, so yeah, that probably should be a little bit hot. 133. Wow. Heat exchange is cold. 82 on the riser. 189. 185. That's the hot joint right there. 186. 170. 171. Okay. That should be hot enough to keep any condensation from forming. Let's take a look at the port manifold. $60. I wonder why that's different. Oh, it's just... Actually, it's 173, 172. Right where the exit is. The exit to the thermostat housing. A little bit of coolant, about half of what was in the tank when we started. Still flushing air, I guess. Still no leaks. So let's get the deck down. She's going to run, you know, 5 to 8 degrees cooler with this setup, at least at light load or no load, 2,000 RPM. So I think this is about as much as I can accomplish here on the hose. The next step is to take it to and splash it and let her feed off of the raw water pump and see what that looks like. but not an inauspicious beginning. All right, it's Wednesday, a really nice day. Not much wind, lake's at full level, full pool, calm out there. So we're going to do our final test, which is a test flight of the new freshwater cooling system, full freshwater cooling system for the Volvo Penta 8.1. Now the differences are that instead of the coolant flowing out of the crossover pipe and directly to the heat exchanger, we've detoured it, run it through a distribution box, run the coolant back to the manifolds, from the manifolds to a remote thermostat housing up there on the firewall, and from that thermostat housing it feeds directly into the heat exchanger. Now the whole reason for testing in on the water load testing is because it's unverified whether the heat exchanger has enough cooling capacity to handle the additional heat loads of the exhaust manifolds as well as the engine. To my knowledge, this is the first time it's been done on a Volvo Penta 8.1. So we've completely set it up for freshwater, or for raw water. Is petcock is open, the flush valve is closed, the coolant, it looks good, the oil looks good, so it's kind of time to put the rubber on the road and light the fires here. So that's next. All right, we've held off a little bit, hoping the water temperature would come up from the low 40s to about 60. It's not quite there, but that's a lot closer for a worst case test of cooling. We don't want exceptionally cold water running through the raw water side, so that we can get a good feeling for how well the heat exchanger is doing its thing. So no more talking, let's light her off and get things started here. Okay, fuel rate, charging the rails, that's done. There we go. And again. All right. Verify water's coming out the exhaust port. Well, that's kind of hard to do since it's underwater. Running the same thermostat and impeller as last year. They were both working fine. I didn't want to make any real changes. I wanted to get a straight up comparison. So we're doing that. We'll do the static test here, and when she comes up to temperature and levels off, then we'll untie and kick off and do some low speed tests. So more in a minute. All right, we've been running about 7 or 8 minutes now. The temperature is seemed to stabilize. Thermostat opened up. It got as high as 174, and then has since dropped back down to about 172. This is a digital readout for engine temperature, analog over here. So I think we're about ready to cast off and do some load testing. Back in a few. Okay, we're moving out into the bay. Doing about 5 miles an hour just off idle. We'll see in 174. Get past some debris. We'll kick it up to tuna trolling, about 8 miles an hour, and see what we get. In fact, let's kind of do that now. There's about 1200 RPM. Roughly 7 miles an hour. Engine temperature still holding at 172. Miles an hour, 1300 RPM. .73. Okay, moment of truth. Let's go for full cruise. I won't be able to talk because the camera will be in my mouth as I need both hands for this. Okay then, we're at 3,200, not quite cruising speed. Degrees. Likes it. I'm liking it. I didn't want to go back to stock. Alright, so that's normal cruise. About 27 knots, 30 miles an hour. Right around 30, a little over 3,200 RPM. But I'm light. I only got 60 gallons of gas on board, and just me. So we're going to take her up to max cruise now, which is 3,800 RPM. Don't want to go to wide open throttle. I suspect we have to at least put that load on. We're holding 172, which is about 5 degrees colder, but the water still, it's not, maxes out around here about 72 degrees. We're about 59. So, okay, a one short brief blast all in. Liking that too. We're not all in. That's all in. $171, 73, 172. Yeah, that's good enough. I'm happy. Boat's happy. Well, I'm calling it good. I'm gonna get some lines wet. See if I can put something on the dinner table tonight. But I think we can say that the freshwater cooling system is going to work, the full system. The Volvo Penta heat exchanger has sufficient capacity to handle the heat load of the manifold.